We can actually look back almost 13.8 billion years, which is very close to the Big Bang. Now we know how our world ends. Our attitude to science fiction movies and maybe the Bible would point to a big bad apocalypse, but what if we told you that the end of the universe is no different than the beginning? The James Webb Telescope showed that the universe has stopped expanding. Popular scientist Brian Cox predicted this years ago. In doing so, he gave us the most realistic starting point for imagining the end of the world. We can look at light that started its journey before the galaxies, and it is the oldest light in the universe, which is another proof for people who don't believe in the Big Bang. The answer is, well, you can see it. We're headed for Big Bang 2.0. Join us as we explore why the world stopped and James Webb's terrifying discovery. If there's one thing we know for sure about the universe and its history, it's the fact that the entire epic of our existence centers around this Big Bang. Of course, there are alternative theories that accept the beginning of the universe, such as eternal inflation or an oscillating universe, but we have not delved into the validity of those theories today, mainly because the astronomical community has now willingly accepted our history. In this universe, it begins with the Big Bang, and the ideas that follow the Big Bang are also based on the same common origin of the universe. Although the Big Bang is a buzzword in the theoretical knowledge of astronomy and space, unless you are a geek who has spent hours looking at a great visualization of the Big Bang, we are almost completely unaware of the facts and means of the phenomenon. Honestly, the phenomenon was more like an explosion, so to speak. Simply put, the Big Bang came from a single point, a point that was infinitely hot and dense, blown to extreme lengths. All this happened when the universe was incredibly young. Believe it or not, the universe was only 10 to the power of negative 34 seconds old at the time of the Big Bang. That's 1/100th of a billion trillionth of an age. This is when the universe experienced an incredible expansion explosion, the infamous explosion or inflation. In this process, space expanded faster than the speed of light. So yes, you wouldn't have blinked when the universe expanded 90 times almost instantly, from subatomic size to the size of a golf ball. Seconds after inflation, the universe began to cool, leading to the formation of matter as we know it today. So yes, according to the timeline, our universe was filled with all the particles we learned about in chemistry class in a second, willy-nilly or otherwise. Protons, neutrons, electrons, anti-electrons, photons and neutrinos are the legacy of the Big Bang. Magical, isn't it? Visually it seems so, but our understanding of the origin of the universe is very theoretical. We've come a long way since the first moon landing, and technological advances have grown by leaps and bounds since then. When scientists studied the Big Bang based only on mathematical formulas and scientific models, they would not have thought that we were studying the possibility of life on Mars. There have been great successes in the exploration of the universe and space, but still our existing technology is quite limited. We cannot recreate the Big Bang or watch the event itself. Our greatest evidence comes from the cosmic microwave background, which allowed scientists to observe the echo of the Big Bang. Although this mechanism is innovative in the study of the universe, it is also theoretically limited. The biggest obstacle to this method is that we cannot see gravitational waves or the residual radiation from the expansion itself. So while all our knowledge is based on theoretical principles, even scientific theories have a lot of room for challenge. Yes, we are pretty sure about the concept of the Big Bang and how monumental it was in the creation of our universe, but we get some of its implications wrong. And as shocking as it is, our theories about the universe are largely based on data that is constantly subject to human error. At the same time, some of our data about the Big Bang is also very compelling. Let's just say it's not easy to completely disprove the theory at this point. Is our universe still expanding? For the past decade, our only lifeline for studying the Big Bang has been the Hubble Space Telescope, and now, of course, all predictions are based on the superb accuracy of the James Webb Space Telescope. Before we had access to these powerful technical instruments, one of the biggest points of contention in astronomical research was the expansion of the universe. If you were to pick up some science textbooks from the early 90s, you would read about how the universe is expanding. In other words, the universe is expanding, and that's one little scientific fact we've been holding on to. But the real snafu here is that we may not understand what the expansion of the universe entails, and more importantly, we have to ask ourselves if the universe is really expanding. Because, spoiler alert, the James Webb Space Telescope tells us otherwise. Here, the universe stopped expanding. And hey, while the world is still intact, you might want to improve your online experience for security, because we sure did. That's why we're happy to reveal our secret to safely browse and access deeply blocked content to make compelling informational videos. Today's video is sponsored by Atlas VPN, the champion of a secure and accessible internet. With over 6 million users worldwide, Atlas is a game changer for everyone. Of course, this service is not available in space, but Atlas would make your internet experience super safe and fast. Can't watch shows related to your region? Connect to Atlas in microseconds. Voila, you're in. You do not need to be a technical or computer expert to use the service. It works like a charm for anyone and everyone. Also only $1.83 a month plus 3 months. So why choose Atlas? Atlas kills malware attacks, keeps your good searches safe, unlocks content from around the world, and offers the best deals on the market. Get everything with one subscription for all your devices. Get a great deal because now Atlas VPN Premium costs only $1.83 per month plus 3 extra months and a 30-day money-back guarantee. Protect your privacy and enjoy the many benefits of Atlas VPN at a ridiculously low price. You can enter this agreement by clicking the link in the video description below. Hurry, this is a limited-time offer. While we thank Atlas VPN for sponsoring this video, click the link in the description to take advantage of the limited-time offer. Your online experience just got better. Have you ever heard of stars that explode every 80 years and still don't die? We are facing a unique space explosion that can be seen everywhere. Unlike a supernova, where stars burn up completely in a giant firework, an old star can also produce so-called nova explosions. The play is also worth watching, and we will not only see it once, but again and again. A nova in the Coronae Borealis system is about to explode, and we eagerly await it. Many people dream of seeing nova from Earth with the naked eye. New are huge thermonuclear explosions that briefly illuminate stars 150 times brighter. We will see the incoming nova as probably one of the brightest points of light in the night sky for weeks. This is great news for space fans. This astronomical treat certainly doesn't come around every day. T Coronae Borealis explodes about every 80 years, most recently in 1946, and now it's happening again. This celestial explosion promises to be one of the brightest and most eye-catching celestial events of the decade. A nova occurs when two stars in a binary system have a strange interaction with each other that releases huge amounts of energy. This then leads to an explosion and a sudden increase in brightness so that a new star appears in the sky. New ones are not only fascinating to observe, but also very interesting from a scientific point of view.
Sometimes it's amazing what happens in our universe, and anyone who knows the true background of the newcomers will be surprised. Is a new star really born? You probably all know the origin of the term new. Nova comes from Latin and means new. Tycho Brahe, a famous Danish astronomer of the 16th century, coined the term when he suddenly noticed a very bright new star in the night sky. He called this phenomenon stella nova, new star, or later simply nova. With the technical possibilities of the time, it really seemed to him that a new star was born. At that time, however, astronomers did not observe the birth of a star, but a violent eruption and subsequent thermonuclear explosion in an existing star system. A nova is actually a fairly short but very bright flash from a white dwarf star. White dwarfs are born when stars the size of our Sun have exhausted their fuel supply. Instead of exploding, they lose much of their size and shrink. White dwarfs in binary systems may then have the ability to absorb matter from their companion star. As soon as the critical mass is reached, an explosion occurs, which we then see as a nova. The difference between a nova and a supernova is simple. A nova forms in a binary system where a white dwarf accretes matter from a companion star. A white dwarf is not destroyed in an explosion. It can even produce several knives over thousands of years. Supernovae are much more powerful events where a star is completely destroyed in an explosion. Type I supernovae have special properties similar to ordinary novae. Again, a white dwarf is involved. But in this case, the white dwarf accumulates so much matter that it cannot survive this final explosion and breaks up. The brightest supernova luminosities are Type II, where a massive star with at least 8 solar masses collapses at the end of its life. The luminosity of a nova is impressive, but it is much dimmer than a supernova. Soon we will see a simple nova from a small white dwarf, which will not be destroyed in the process, but will give us a spectacular light show. When the time comes, the white dwarf will suddenly increase in brightness more than 1,000 times. Such events are usually only visible through a telescope, but in this case, the nova is so close that we can see it with our own eyes. Basically, the brightness of novae and supernovae that we see from Earth always depends on the distance, their location. A nearby nova may appear brighter to us than a very distant supernova. The next supernova visible from Earth is the explosion of the star Betelgeuse. Scientists still don't know exactly when that will happen. Maybe tomorrow, maybe not for several thousand years. However, we will definitely see the white dwarf T Coronae Borealis nova, and the next one will almost certainly come in 80 years. Although T Coronae Borealis is 3,000 light-years away, it is more than 3,000 light-years away from us, and yet we can see it very well with the naked eye. The binary system is located in the constellation Coronae Borealis. This white dwarf is a very dense remnant of a once sun-like star. After the original star used up its nuclear fuel, its core collapsed. The outer layers were pushed out, leaving a white dwarf. The companion star from which the white dwarf collects material is a red giant. This star is also nearing the end of its life and has begun to expand. These outer layers gradually attract the white dwarf and accumulate until conditions are suitable for a thermonuclear explosion. This explosion then dramatically increases the brightness of the white dwarf, giving us a nova. According to predictions, the nova will reach a brightness of about 2.5 magnitude. This means that the apparent new star will then be one of the brightest objects in the night sky for a few days or even weeks. Even if you live in a city in places with a lot of light pollution, you can see a bright spot in the night sky with the naked eye. The Coronae Borealis constellation is also called Northern Corona in some star charts. The constellation is easy to find, as its semicircular shape makes it easy to spot in the northern sky. It lies between the two somewhat better-known constellations of Boötes and Hercules. If you look between the two, you will see very bright stars forming an arc. This is Coronae Borealis. The brightest star at the top of the arc is Alphecca, sometimes called Gemma. From Alphecca, you can easily follow the other stars of the arc and easily identify the entire constellation of the Northern Crown. Now it is best to look in that direction and memorize the constellation. After the explosion, a very bright new star can be seen there. It is new. The best time to see the nova is in the late evening when the Coronae Borealis is high in the sky. A thermonuclear disaster every 80 years is crazy. We enjoy a fantastic glow on Earth, and in fact, a destructive inferno is going on in this world 3,000 light-years away. An approaching nova in the T Coronae Borealis system is an event that occurs in a fixed order every 80 years. The first known explosion of T Coronae Borealis was observed in 1866. During that time, a bright star suddenly appeared in the night sky, which was noticed and recorded by many astronomers of the time. This phenomenon happened again in 1946, exactly 80 years after the first sighting. Astronomers around the world are studying the 1946 eruption in even more detail. Additional historical reports of Abbot Burchard von Herber from 127 indicate that the nova was a companion to humanity for a very long time. Herber observed unusual brightening in the Coronae Borealis region in recent years. Astronomers have noticed increased activity in the T Coronae Borealis system. Since 2015 and 2016, there have been repeated unusual fluctuations in brightness and sharp increases in radio and X-ray emission, both clear signs of an imminent eruption. The observations are also similar to activity documented by astronomers during earlier eruptions in 1866 and 1946. Already in 2018 and 2023, there were noticeable fluctuations in brightness that made scientists sit up and take notice. They compared their data with data from 1946 and found striking similarities. These repeated signs almost certainly point to the next new one in September 2024, when we may see a light that will be one of the brightest in the night sky for several weeks. This white dwarf is likely to produce many more noses after this explosion. It could take millions of years to completely collapse or trigger a Type I supernova. We do not know the exact number of potential newcomers. We have not observed this phenomenon long enough. Scientists calculated in simulations that the number and periodicity of novae depend on several factors besides the amount of accumulated matter and the efficiency of the reproduction process. They say this is due to the rotation of both stars, as well as the differences the two have between them. In a periodic news system like T Coronae Borealis, the white dwarf continuously pulls in material from its companion star, a red giant, and that material then forms an accretion disk. The mass is slowly reaching the surface of the white dwarf. Now, of course, the question arises as to why the absorbed substance explodes. The matter accumulated on the surface of the white dwarf consists mainly of hydrogen. When the mass of this hydrogen layer reaches a critical density, thermonuclear reactions begin. The reactions release huge amounts of energy. Think of it as a giant hydrogen bomb. When it goes out, there is a sudden brightening and the nova becomes visible. We look forward to more new ones. Systems containing white dwarfs and red giants are such extreme places that they are actually no longer inhabited, so we can continue innocently enjoying the beauty of the newcomers. While all eyes are currently on T Coronae Borealis, we can report that more novae in other star systems are coming soon.